Welcome, everybody. I'm Federica Pederzani, 3D Product Manager of Stonex. And now I'm going to show you our solution, which is called XVS. So this is a scanner based on Vslam technology, which integrates a Vslam camera and a camera. Then the data are managed via photogrammetry techniques. To enter more into the details, I show you how it is made. So it's made, of course, by a RGB camera, which has a global shutter sensor. This is important because the pictures will be more stable, and so at the end also the resulting point cloud will be better. Then we have a Vslam camera, the one on the left, which is very helpful in the field because thanks to this visual camera, the customer, the end user, is very confident about the data he will obtain. Then there is also an IMU, which is, of course, very helpful for leveling your data. The dimension of the device is small and compact. It's around 740 grams, so very light also for holding it. And then there is an USB Type-C connector for giving power and communication. So in this way, data are saved directly in a tablet, and you are sure about the communication and the data saving. The system is very, very easy. You don't need to have knowledge about photogrammetry, about scanning in general, because the system guides you while you collect the data. So you see in this screen, we have, there are two images. The one on the left is the one from the RGB camera, which shows you the quality of the images that, of course, you can calibrate, modify the contrast, saturation of the images, and all the parameters. The one on the right, instead, is showing the Vslam camera. And in that image, in that part of the screen, there are some red dots, which are the homologous points used for photogrammetry, which are some details in your images which will allow the connection of all the images in the photogrammetry processing. Then another important part of the screen is the one on the right, where you see there are two green dots. These two green dots are representing the quality of your data. So if the dots are green, you can be sure that the data will be fine and you will obtain a good final point cloud. In particular, one of them is related to the quality of the data, and the other one is related to the leveling status of your point cloud. Because, as I said, thanks to the IMU, the data you will collect will be leveled. Another key point of this system is the possibility to scale your 3D model using these stereo targets. These stereo targets are actually made by two targets coded with a known distance between them. And so the system will automatically know the distance between these two targets that you can place in the environment you are scanning. And the user doesn't need to collect ground control points with the GPS, total station, or whatever. So it's a very good added value for customers that are not skilled. Of course, because this distance between the two targets is limited, you can use these targets for limited environments, which has maximum area of around 900 meters squares. Otherwise, if you need to survey larger environments, of course, there is a possibility to use ground control points and measure them using total station or GPS, or also measure relative distances between ground control points, maybe with a disto, which is easier if you don't have topographic surveyor skills. All the data you collect are shared via cloud service. And in this way, the customer just have to load the project via cloud, via this, on that interface, and define which are the parameters of the 3D model he wants. So just the quality of the 3D model and format he wants to obtain, point cloud or a mesh different formats. Behind this cloud service, there is a smart algorithm which is working. So starting from all the project, all the huge amount of images collected by the system, there is this algorithm which selects the best one, the ones that are better in terms of color, detail, that are not blurred, and so on. So in this way, of course, choosing the best images, also the final 3D model will be in the best way as possible. Now I would like to show you some case studies made with this device. Of course, for sure, this XVS is a very good product for archaeological sites because you can obtain very high resolution and details in the point cloud. So here we are in Spain, in this Casa del Mitreo, and in this case study, we checked the quality of the results, comparing them with the total station. Here you can see the point cloud we got. So it's a short video showing you the resulting point cloud of the area we have scanned. And these are the results compared to the total station. So we measure 8 elements in the environment, 8 points. And you can see the comparison between each point from the total station and the same point selected in the point cloud. We can obtain RMSE, which is around 5 millimeter in all the direction, X, Y, and Z. And the last column is the error in the 3D. Another data set, another case study is this room in Monza. This is a dancing floor of Villa Reale, and since it is open to public for visiting, for tourism, the floor is damaged. So the Villa Reale architect wants to restore the floor because we had the possibility to assess and scan this environment, we also made the scan of all the room that you see on the right. But let's focus now on the floor. This is the point cloud on the right and a video made with a professional camera on the left. So you see how good is the resolution that you obtain with XVS. We created the orthophoto, which was the deliverable requested by the architect. And we can highlight some parts of the floor that has higher damages, where you can see there are some holes, some scratches. After this orthophoto, we also evaluated. We wanted also to evaluate how deep these holes are. So we fitted a plane in the surrounding of the hole, and we compared the 3D model with the plane. And so it's visible where the holes are located. You see them in blue. Okay. Another case is a part of the excavator, the bucket. We received some requests from customers that need to create parts of the excavator because working they break. So in particular, sometimes they ask for parts of the excavator, sometimes for the bucket. And even if the reflection of the elements is not an easy environment for photogrammetry, we obtain good results. And this is the 3D model. After the 3D model, you can see here the X-ray orthophoto of the bottom and the lateral views, where you can see that you can easily build the geometry of the element. And in fact, this is what has been drawn with the CAD. Okay, thank you everybody. If you want to know more about this solution, you can come to the hall 27 and we can show you how the device works.